Data centers have, I think this is is in 2008, data centers were the sixth largest consumer of electricity in the country. And looking at the economy today, we may have actually moved up to 4 because most of the manufacturing jobs have gone off. So, and world data center power consumption was a few years back, it was between all of Mexico and all of Iran. And maybe, again, that would have gone up by now again. So this is just to show the rate of growth of power consumption in data centers. Just to take a look at the price comparison of power, energy in several of these countries. US is not the most expensive country for power. Actually, China was at about 20. I was there a few weeks back and I had the same discussion and they came back with 20 cents per kilowatt hour and we are at about 9 on average. Still, half of the power used in a data center is still used for IT and the other half for cooling. So this is the part that we can actually optimize and save on total energy consumption. But what we offer is can we change, if we could change the airflow distribution and match the heat distribution dynamically. So as the heat distribution changes through the day or through the year, if we can manage to match the airflow distribution, you could get the maximum efficiency. And this is the amount of savings you can have. And this is a source of shutting down this 150, 110 tons of cracks. You get higher capacity because you have more cooling available, you have energy savings, and you have a thermal safety where you have extra standby cracks just in case you need it. So we call it demand-based cooling, DBC. That's a whole system of networked air movers, floor-mounted air movers, ceiling-mounted air movers that are all connected to a central controller and a whole lot of sensors within the data center that is monitoring the thermal signature, thermal profile of the data center. And as the temperature changes, the airflow distribution is varied to match the need. And just enough to bring the temperature points under control. So you're bringing just enough airflow to a rack to cool it, nothing more, nothing less. And we also talk to the cracks, and we could turn them off or on just in case another crack fails. We could turn something else on and redistribute the flow. If the heat load increases, the system automatically turns on the next crack. It talks to the building automation system to report alarms or anything, or talk to other cracks on VFDs or such. It has interface going out to the web, text, email, if there's alarms or status that need to be reported to personnel.